I'm going to work out the problem that we had in Go Formative on balancing redox reactions today, just to make sure I didn't leave any of you confused from class. So the first thing you always do when balancing a redox is to assign oxidation numbers to every single atom, and so I am going to do that right now. Let's see, so manganese is +7 on the reactant side. And let's see, collectively the carbons have to be +6, which means each carbon is +3. Doing my math on the bottom. All right, so I have oxidation numbers assigned for all elements now, and I'm going to look and see which ones have changed from the reactant side to the product. And I see that manganese has gone from +7 to +4, which means it has gained 3 electrons. 7 minus 3 is 4. And gaining electrons, that is our reduction half reaction. And what else has changed here? Carbon has gone from +3 to +4, which means we have a gain here of, or a loss, excuse me, of 1 electron. And losing electrons means oxidized. Once you have identified what has been oxidized and what's been reduced, you can break them into the half reactions. So the oxidation half reaction, I'm going to write on the left here. And the reduction reaction, I'll go ahead and write on the right. Okie doke. So step 1 is to balance the atoms. Always save oxygen and hydrogen till last. So I see there are 2 carbons on the reactant side. I'm going to put a coefficient of 2 here. And I need to balance oxygen. 2 times 3 is 6 oxygen on the product side. So I add 2 water molecules, which will give me a total of 6 oxygen now on the reactant side. After balancing oxygen, you need to balance hydrogen. And so right now I have 4 hydrogen on the reactant side, and we use hydrogen ions to balance hydrogen. Whoops, that's supposed to be a 4. All right, now comes the tricky part. When all the atoms are balanced, you need to balance the charge. So you need to total the charge on both sides. So to do this, any substance that has a charge, just look for a superscript and add them all together. So the reactant side has a total charge of -2. It's the only thing that has a charge here, C2O4. The product side, we have each carbonate has a -2 charge, but there are 2 of them. That's -4. And then we have 4 hydrogen ions, so that's +4. So charge on the right side, on the product side, is 0. Charge on the reactant side is -2. So in order to get the charges to be the same on both sides, we need to add 2 electrons to the product side. Okay. And now both sides have a charge of -2. So moving on to the reduction half reaction. The manganese are already balanced, so I'm going to add water to balance the oxygen. And now I have 4 hydrogen on the product side, so I'm going to add 4 hydrogen ions on the reactant side. Now I'm going to total up charge. The charge on the reactant side is -1 plus 4. So altogether it's +3 on the reactant side. On the product side, there's no charge. Nothing has a charge there. So I need to add 3 electrons to the reactant side. And that gives the reactant side a net charge of 0 now. All right, so everything's balanced in both of them now. And before you can add them together, they need to have the same number of electrons. So we have 2 electrons now in the oxidation half reaction, and we have 3 electrons in the reduction half reaction. So you need to find the lowest common factor, and so I'm going to multiply the oxidation half reaction by 3. That'll give me 6 electrons. And I need to multiply the reduction half reaction by 2. So I'm going to rewrite them both just to make sure we're on the same square at this point. And make sure you multiply every single thing in the half reaction by 3, because otherwise your ratios will be off. It won't be balanced anymore. Alrighty. And I'm going to multiply everything in the reduction half reaction by 2. I'm going to spill to the next line here. Alrighty. Now simply add both balanced equalized half reactions together. And when I do that, let's see if I can squeeze all this in. I think I'm going to erase the top part and move up there. I don't want to go to another page because I want you to be able to see the work if it helps. All right, so I'm going to go to the top here and combine reactants from both half reactions together. Oops. All right, that's it for the reactants. Now I will move on to products. Phew, it gets quite tedious. All right, so now that you've added everything together, you want to cancel out the things that are the same on both sides and or simplify. So the electrons should always cancel, should always be the same. And then typically you're going to have to simplify. If water shows up on both sides, you're going to have to simplify that as well as the hydrogen ions. So find the side that has more of them. So in this case, we have more water molecules on the reactant side. So we're going to subtract 4 water molecules from each side, which makes them go away on the product side. And 6 minus 4, so I'm going to end up with 2 water molecules on the reactant side. Simplifying the hydrogen ions, I'm going to subtract 8 hydrogen ions from both sides, which will give me 4 hydrogen ions on the product side, and they'll go away on the reactant side. And I'm going to rewrite it all. Okay. So my net final balanced reaction is and that is it. Takes a lot of practice, very tedious and very easy to make a mistake.